Welcome to all. Good morning. I am Rajkumar Lakshman Mankar giving a presentation on title Mechanical and Tribological Investigation of a Coated Steel with Dr. A. Keste sir. Introduction. Index. In this presentation, I will explain with the topics abstract, introduction, materials and methods, results and discussions, conclusion and references. First of all, abstract. In present investigation, TIAN, TICN and chromium CRN multi-layered coating thin films have been developed. They consist of superposing chromium, nitrogen, TIC, TII layers. These coatings were grown on AISI 4140 steel samples. The mechanical and tribological properties of these coating is to be characterized by adhesion test, scratch test, X-ray diffraction test, XRD means, and scanning electron microscopes SEM. Characteristics of a arc PVD CRN coating formed on plasma nitrided and as received surfaces of an hardened AISI 4140 steel before and after nitriding have been examined by the adhesion and the wear tests. CRN coating deposited on the nitrided surface exhibited remarkable advanced properties as compared to the CRN coating deposited on the as received surface. Introduction. Gas nitriding is a thermochemical surface treatment in which nitrogen is transferred from an ammonia atmosphere into the surface of steels at temperatures within the ferrite and carbide phase region. After nitriding, a compound layer and an underlying diffusion zone, that is KS, are found near the surface of the steel. The compound layer, also known as the white layer, can greatly improve the wear and corrosion resistance. The hardened diffusion zone, which is composed of interstitial solid solution of a nitrogen dissolved in the ferrite lattice and nitride and or contributed perceptions for the alloy steel containing the nitride forming elements, is responsible for considerable enhancement of the fatigue endurance. Furthermore, being a low temperature process, nitriding minimizes the distortion and deformation of the heat treated parts. Therefore, the nitriding is an important surface treatment for ferritic steels. The properties of a nitrided steels are determined by the nitrided case microstructures to ensure the reproducible and desirable properties from batch to batch. The gas nitriding need to be controlled to ensure the microstructure evolution. The successful gas nitriding process control depends on process parameters selection to meet the specification. Accurate process parameters control during the process. The gas nitriding process parameters include temperature, time and the nitriding atmosphere. For the nitriding atmosphere control, the ammonia dissociation rate was traditionally adopted as the controlling parameter. It is represent the percentage of ammonia dissociated with hydrogen and nitrogen and is manually measured by using a burette in the furnace exhaust gas. Since dissociation rate is not an in situ measurement and the measurement is done manually, it introduces operator include variability and cannot provide the accurate control on the nitriding process. With the development of measure and control system, the gas nitriding process parameter can be controlled accurately. How to predefine the nitriding process parameters to meet the specifications becomes the main challenge of the gas nitriding process control. Conventionally, trial and error methods were used to define the nitriding processes parameters to meet the specifications. These methods is expensive, time consuming and hard to control. Therefore, an effective simulation tool is needed to define the process parameters based on the performance specification of various steels. By using this tool, the properties of the nitrated steel based on the phase constitution, surface nitrogen concentration, profile, case depth, as well as growth kinetics can be simulated through variation of process parameters, temperature, time, and nitriding atmosphere. Materials and methods. Nitriding and coating. Nitriding is the heat treatment process that diffuses nitrogen into the surface of a metal to create a case hardened surface. These processes are most commonly used in low carbon, low alloy steels. Gas nitriding is an important thermochemical surface treatment that is used to improve the wear and corrosion resistance as well as the fatigue endurance of steel parts. Accurate process control is the effective way to ensure the property reliability of nitriding process. Gas nitriding. In gas nitriding, nitrogen is introduced into a steel surface furnace, a controlled atmosphere by holding the metal at suitable temperature. In coating with nitrogenous gas, usually ammonia, NH3. The process represents one of the most efficient among the various methods of improving the surface properties of engineering components, especially the parts with complicated shapes requiring homogeneous hardening the surfaces. Plasma nitriding. Plasma nitriding uses plasma discharge technology at lower temperature to introduce nascent nitrogen on the steel furnace. It is another well established surface hardening process in steel and also known as a ion nitriding. Plasma is a forming of by a high voltage electrical energy in a vacuum. Nitrogen ions are then accelerated to impinge on the workpiece which is connected as a cathode. The ion bombard, bombardment heats the workpiece, cleans and the surface and provides the nascent nitrogen of diffusion into the steel material. Pack nitriding. Pack nitriding uses nitrogen being organic components as source of nitrogen. The steels are packed in a glass, ceramic or aluminum containers together with the nitriding compound which is often dispersed in a intent packing media. Upon heating, the organizing component used the process from reaction products that are relatively stable at the temperature up to 570 degrees Celsius. The reaction products are decomposed at the nitriding temperature and they provide a source of nitrogen. The process time can range from 2 hours to 16 hours. Salt bathing. Salt bath nitriding. Salt bath nitriding process is carried out in the molten salt bath. It can be applied to carbon steels, low alloy steels, tool steels, stainless steels and cast iron. The case hardening medium is a nitrogen bearing salt bath containing cylinders of cyanides. During the process, the dimensional stability of the workpiece can be preserved. Thus, processing of finished parts is possible. This implies that it can be used to complement engineering properties developed during the carboizing and carbonate nitriding. Name of the material AISI 4140. Chemical composition, that is percentage in weights. Carbon 0.4, silicon 0.3, manganese 0.1, chromium 1, nickel 0.2, iron 97. Sample size for wear test on pin on disc machine, diameter 8 mm by 30 mm length. Procedure to prepare sample: first nitriding, then coating of TiN, TiCN, wear test on pin and disc machine. Result and discussions. Wear test. Experimental setup. In setup. In pin on disc tribometer TR20, a flat pin is loaded onto the test sample with a precisely known weight of 17.63 kg. The pin is mounted on the stiff lever designed as a frictionless force transducer. The deflection of the highly stiff elastic arm without parasitic friction ensures a nearly fixed contact point and thus a stable position in the friction track. The friction coefficient is determined during the test by measuring the deflection of the elastic arm. Wear efficients for the pin and the disc material are calculated from the volume of material lost during the test. This simple method facilitates the study of friction and wear's behavior of the almost every solid state material combination with the or without lubricant. Furthermore, the control of the test parameters such as speed, contact, pressure and wearing time allow a close reproduction to the real life conditions of practical wear situations. It also facilitates study of friction and wear characteristics in sliding contacts under desired conditions. Sliding occurs between the stationary pin and rotating disc, normal load, rotational speed, and its wear track diameter can be varied to suit the test conditions. Specification of a pin on disc friction and wear monitor TR20 is given in this table, that is Make and Magnum Limited, Bangalore Limited. Pin diameter range 0.3 mm to 12 mm, disc size 160 mm to into 8 mm, wear track diameter 0.5 mm to 150 mm, sliding speed range 0.25 to 12 meter per second, disc rotation speed 100 to 3000 rpm, drive 1.1 kW DC motor controller, thyristor converter with full motor protection, frictional force 0 to 250 Newton, normal load 0 to 250 Newton, disc material EN31 with hardness 60 HRC and RA 0.3, wear measuring range plus or minus 2 mm, digital readout with the recorder, power 230 volt 15 ampere, one phase 15 Hz AC, make Magnum Limited, Bangalore, India. Scanning electron microscopy, that is SEM. Sample size is 0 diameter mm, 0.8 mm into 10 mm length. Scanning electron microscopy is one of these characterization techniques whose data is used to estimate the properties, determine the shortcomings and hence improve the material. The phenomena of superconductivity initially develops with the grain and eventually crosses over the grain boundaries, leading to the bulk. Hence, SEM can be useful tool to probe the microstructure of the superconductors and the properties related to it. Along with this, the energy dispersive spectroscopy, that is EDS, can tell about the chemical composition of compounds, grain size and its connectivity can be seen through SEM and can be correlated with the corresponding properties. In SEM, electron beam is scanned across a sample surface. When the electrons strike the sample, a variety of a signals arises and produces elemental composition of the sample. Conclusions. From scratch test measurements, the yield stress of steel and nitrided steel can be determined. A comparison of a scratch test results on untreated and nitrided steel showed that nitriding makes the steel harder and more brittle. It is shown that duplex coating with the good adhesion between the nitride substrate and CR2N layer can be obtained even if some iron nitride is present at the interface. Samples made of AISI 4140 steel pre-treated with plasma nitriding and coated with the different PVD coatings. Investigation showed improved mechanical and wear properties of the plasma nitride hard coated specimens compared to